All right, this topic is not necessarily calculus, but it is a topic that's going to help us with our next calculus topic. So it's called partial fractions, and let's get started. Our goal here is actually to turn this one fraction into two fractions, and the first fraction being some number over 2x minus 3 plus some number over x minus 1. And these two things will be equivalent, but it's going to be much easier to find the integral of this than it will to find the integral of that. So how do we do this? Well, we're going to start with what we want, which is what I have in red there, and we're going to multiply by the binomial that is missing, meaning here I'm going to multiply by the x minus 1, and I'm going to also multiply by x minus 1. Essentially, I'm multiplying by 1. That fraction is x minus 1 over x minus 1, which is 1. Then similarly, on the right side, I'm going to multiply by the 2x minus 3. Just like that. And you can see that the reason I'm doing this is because I want to have a common denominator. Okay, so this is going to be equal to a common denominator of a 2x minus 3 times an x minus 1. See how both of these have exactly that same thing. They may be in a different order, but we know multiplication, it can be in any order. All right, let's go ahead and let's multiply this through here. So I'm going to multiply this times this. That's going to give me an ax minus a. And then I'm going to multiply this. That's going to give me a 2bx. And then b times a minus 3 is a minus 3b. All right, the next thing that we do is a little bit different. And I'm going to go ahead and color code this here. I'm going to call this a 1x here. So in purple, anything that has an x with it, I'm going to color purple. So I'm going to call this an ax, and I'm going to call this a 2bx in purple. And I'm going to rewrite this as ax plus 2bx right next to each other, because notice the x's are first here. And then the other two things that are missing are just numbers or constants, and I'm going to go ahead and give that a, I don't know, a black. So this is going to be a minus a and then a minus 3b. So minus a minus 3b. All right, and that is still over my 2x minus 3 times x minus 1. Now here's where something gets a little funny. What we're going to do is try to model our purple and black to look exactly like what we have right here. So I'm going to pull out an x. And so I'm going to have that this is equal to a plus 2b, all in parentheses, and then x, because notice how they both have an x in it, so I just pulled out the a plus 2b. Now remember, I just said to you that I want to model what I have here, and what do I have? I have a minus. Okay, so I'm going to keep the minus right there. That's really important. And then I need to write this stuff right here. Well, if I have a minus and I want a negative a, I'm going to have a positive a inside, because a minus times a gives me minus a. And then I'm going to have a plus 3b. And the reason why is because a minus times a 3b gives me my negative 3b. All right, and that is still all going to be over a 2x minus 3 times an x minus 1. All right, what we're going to do next here is we're going to set up a system, okay? Because what we know right here is that the number in purple here, that number in front of the x is 1, so that this right here needs to be 1 as well. So we're going to have a plus 2b equal to 1. And then we need to realize that our black part is going to be equal to 5. So let me show you that. So we have the minus, So we have the minus, and then this thing right here should be 5 because this thing right here is 5. So I'm going to have an a plus 3b is equal to 5. Now I'm going to solve this problem by elimination, and to do that it's going to be helpful to multiply the top equation by a -1. So I'm just going to put negative in front of all of those. Let's go ahead and add straight down. A -a plus an a disappears. 3b and a -2b gives me a positive b, and 5 minus 1, or -1 plus 5, that's going to give me that b is equal to 4. Okay, so now I have my answer, b is equal to 4, and I can go ahead and solve for a. So why don't I take this equation right here, a plus 3b, and instead of writing ab, I'll write 4 is equal to 5. So that's going to give me a plus 12 equals 5 minus 12. The 12's disappear, and I'm left with an a is equal to -7. So we are done except for rewriting it as what we wanted here. So our final answer is going to be our a, which is a -7 over my 2x minus 3. And then I'm going to have a plus, and then my b, which is going to be 4 all over x minus 1. And we've done it. I'm going to do one more for you. If you feel like you've got this, you can go ahead and move on, but I'd recommend maybe pausing this video, trying this particular problem, and see if you get it right. And the reason why is this one's a little different with the plus here. I wouldn't quite abandon me yet without trying this problem. All right, so I'm going to go through this one a bit faster. So this is going to be hopefully equal to an a over something plus a b over something. Well, the first thing we should do is factor this, and that's going to be an x plus 4 times an x plus 5. So this should be an a over x plus 4, and then a b over x plus 5. Sweet. All right, next step is going to be to multiply by the fraction that is missing. So in this case, I'll multiply by x plus 5. And this would be an x plus 5. Here I'll have an x plus 4, and then an x plus 4. So multiplying that through, that's going to give me an ax plus 5a, that's from this, plus a bx plus 4b, that's from that. And that's all going to be equal to, or not equal to, but over x plus 4 times x plus 5. So now let's rearrange this. I want my x to be out in front, so my ax and my bx are going to be an a plus b, parentheses x. And now this time I want a plus, which is actually easier, so I'm going to put a plus, and then I'm going to put my 5a and 4b. So 5a and 4b. Essentially, if you had a 1 and you multiplied it, that's a match with what I have over there. But we don't need to write that plus 1. And this is still all over our x plus 4 times our x plus 5. All right, now we have to do our solving of systems. And so this a plus b is going to be equal to 3. And we're going to have 5a plus 4b is equal to 10. Now, solving this system is a little bit more work, but we can certainly handle it. I'd probably multiply the top equation by -5. So that's going to give me a -5a minus a 5b equals -15. And then just rewrite this equation here as 5a plus 4b equals 10. So this will cancel, and then we're left with a -b is equal to -5, and then multiply by -1 on both sides, b equals +5. And then I can quickly come up to here and realize that I can plug that b in there. So that would give me an a plus a 5 equals 3. Subtract 5, and I get a is equal to -2. So what's my final answer going to look like? Well, remember we were trying to get it as a over x plus 4. So in this case, we're going to have, instead of an a, I'm going to have a -2 over x plus 4. And then I'm going to have plus my b over x plus 5. And my b in this case was 5. And we are done. Thanks for watching. That's partial fractions.